This video will introduce how to build a Mech-Viz project to guide the robot to pick cartons. First, we need to configure the robot and scene models. Then, build the workflow and finally simulate and run it. Before proceeding with specific operations, let's look at the scene objects and the tool center point. In this video, the tool is a vacuum gripper containing an array of suction cups. To avoid collisions between the robot and the surrounding objects during picking and placing, we need to add the tool model and scene object models in the Mech-Viz project. TCP usually refers to the point at the tip of the tool, which, in this example, is the center point of the suction cups. It can be adjusted according to the actual picking requirements. Next, let's introduce the specific operations. Before setting up the Mech-Viz project, make sure that the master control communication configuration is completed and that the robot is successfully connected. First, configure the tool by adding the suction cups model in the OBJ format to the model library. Then, configure the suction cups parameters and set the TCP in tool configuration. First, configure the tool by adding the suction cups model in the OBJ format to the model library. The TCP is at the robot's flange by default. We need to adjust it to the actual tool center point. To avoid collisions during motion, we need to add collision models of the scene objects. After configuring the settings, click on Sync Robot to ensure that the simulation robot and the real robot have consistent poses. After completing the preparatory work, let's organize our approach to building the workflow. Move the robot to the initial pose using Step Fixed Point Move. Trigger the Mech-Vision project using Step Vision Look. The project will then capture images and calculate the carton's pick points. After Step Vision Look, we add Step Check Look to verify if there is a vision result. Now, move to the approach waypoint. When picking a carton, if the robot moves directly from the initial pose to the picking waypoint, there may be a collision with a carton. We need to set an approach waypoint and use Step Relative Move to let the robot move above the picking waypoint. To pick a carton, first, use Step Vision Move to guide the robot to the picking waypoint, and then, trigger the suction cup to grip the carton using Step Set DO. To wait until the carton is stably gripped by the suction cup before the robot moves, we add a Wait step. Let the robot lift the carton and move to the departure waypoint above the picking waypoint. Use Step Relative Move to set the departure waypoint because it is a waypoint relatively above the picking waypoint. To optimize the path between picking and placing, we need to add a transition waypoint between the departure waypoint of picking and the approach waypoint of placing. Move the robot to the transition point to avoid collisions. Now we place the carton. Move the robot to the approach waypoint for placing, which is to help the robot place the carton stably. Set the placing waypoint in Step Fixed Point Move, and use Step Set DO and Step Wait sequentially to let the robot move to the placing waypoint, release the carton, and wait until the carton is fully released before moving. To achieve repeated picking and placing, we connect the exit of Step Wait to the entry of Step Initial Pose. According to the project construction approach mentioned above, let's build a workflow by dragging out the steps from the step library and connecting them. Taking Fixed Point Move as an example, find this step in the step library and drag it into the workflow by holding down the left mouse button. Then, select the exit of Start, hold down the left mouse button, and connect it to the entry of Fixed Point Move. After dragging out all the steps and completing the connection, we can start to set the parameters of each step. First, set the initial pose of the robot to move the robot close to the workspace without blocking the camera view. Then set the service name in Step Vision Look. Here we select the Mech-Vision project single case cartons we constructed before. Executing this step triggers the corresponding Mech-Vision project and obtains the vision result. Step relative move 1 is to let the robot reach the approach waypoint. Its reference waypoint is that of vision move, so we set the parameter relative move dependency to next waypoint. In this example, the approach waypoint can be located at 300 mm above the picking waypoint. Select the tool reference frame, and offset the z-axis coordinate of the tool by 300 mm in the negative direction. Next, trigger the suction cup to grip the carton. In the parameters of step set DO port to 1, and set digital out value to 1. The values are for reference only and should be determined based on the actual on-site situation. To ensure a stable gripping on the carton, a short wait is required here. The default wait time is 1000 ms, and the wait time can be adjusted according to the actual situation. Next, to avoid collisions, the subsequent path from picking to placing needs to be optimized. Step relative move 2 is to let the robot lift the carton and reach the departure waypoint. The departure waypoint should be set referring to where the vision waypoint is, so we set the parameter relative move dependency to previous waypoint. To prevent collision with other cartons, the lifting height needs to be greater than the height of the carton. Fixed point move 2 is for the transition waypoint, which ensures that the held carton will not collide with other objects in the motion path. Step relative move 3 is to let the robot go to the approach waypoint for picking, which is above the placing waypoint. The approach waypoint should be set by referring to the placing waypoint, so we set the parameter relative move dependency to next waypoint. In this example, the approach waypoint needs to be set 200 mm above the placing waypoint. Similar to the relative move step above, we select the tool reference frame, and offset the z-coordinate of the tool in the negative direction by 200 mm. Step fixed point move 3 sets the placing waypoint. In this example, we set the placing waypoint by defining the TCP when placing. After the robot moves to the placing waypoint, the carton needs to be released from the suction cup. In step set DO port to 1, and digital out value to 0. The values are for reference only and should be determined based on the actual on-site situation. The parameters of step wait are same as above. After completing the construction of the workflow, we can view the simulation results. Confirm that the simulation robot can complete the pick and place cycle normally, and click Run to move the real robot. Note, the operator needs to pay close attention to the movement trajectory of the robot, and press the E-stop button in time in an emergency. So far, we have implemented the vision guidance for the robot to pick cartons. In addition to single carton picking, we can also perform picking with positional offsets on suction cups, and simultaneously pick multiple cartons. Please stay tuned for upcoming tutorials on specific implementation methods.